My name is Damon Ennis. I am SVP of Products at Silver Peak, and happy to walk through the product set with you guys. So first, what comprises our SD-WAN solution? It's our Unity EdgeConnect family, and there's basically three components of that. The first is the Unity EdgeConnect devices itself. That's the device or the software that sits at the edge of the network and provides the key components for the SD-WAN fabric. It comes in two form factors, both a physical and virtual form factor. In the next slide or two, I'll go through some of the various physical form factors we offer. Independent of form factor, the way that the solution is licensed is a subscription offering that's $199 per month per site, regardless of form factor, regardless of bandwidth. It's a very simple pricing mechanism. The edge devices themselves feature a number of key components. The first is zero-touch provisioning. So a very simple way to deploy an appliance in a branch or a resale location, something where a non-educated end user can take an appliance, plug in power, plug in the network, and it shows up on the Orchestrator, which I'll talk about in a few minutes, and gets admitted onto the network. Second key component of what we're delivering with EdgeConnect is dynamic path control. So the ability to leverage multiple paths to give you optimal performance for your applications. So you could be leveraging two MPLS circuits, you could be leveraging MPLS plus internet, two internet circuits, could be a broadband connection plus a 4G LTE, whatever it is. The key there is that by leveraging multiple paths through the network, we can provide private line type reliability and guarantees over much more cost-effective and much more available connectivity options.
How many paths possible?
How many paths are possible? We'd support up to 10, actually. So it's kind of as many as you can. In terms of physical interfaces, there's 6 physical interfaces on the box. Sometimes you're going to have to go to VLANs and things like that to leverage more paths. But yeah. Thanks. The devices build a fully meshed IPsec AES 256-bit encrypted network. Obviously, if you're leveraging the internet, things need to be encrypted. In fact, even if you're using MPLS, you probably should be encrypting your traffic as well. I think less and less these days, people are going to trust anybody to tell them that their network is truly private. Along with the 256-bit AES encryption, we also support WAN hardening on the incoming interfaces. So the only packets that are allowed into the network are those that are trusted by another Silver Peak device. Path conditioning, I'll go through in a bit more detail in a few more slides, but that's some of our key technology that enables internet links to perform very, very reliably. Internet links are not as reliable as private lines. They're subject to out-of-order packets and packet loss. So we've got some technologies that can compensate for that, make those links perform very reliably on their own. And then finally, there's cloud intelligence to give you the best path to route towards SaaS applications. So as more and more applications are delivered by SaaS, so things like Office 365 and Salesforce.com, we've got some intelligence in our networking that we can find the best path from the end user to the cloud delivered application across the Silver Peak SD-WAN. Orchestrator is sort of where it all comes together. Orchestrator is sort of the brains behind the network. It's a single VM that typically lives on-prem in the customer's data center, provides single screen administration, does the automated business intent policies. I'll go through those in a bit more detail later. The business intent policies are really what puts the sort of software defined in our software defined WAN offering. Orchestrator gives you visibility into not only legacy applications that might be going to your data center, things like file sharing and legacy email, but also visibility into all the cloud applications. So everything that's going to SaaS offerings, that's all being delivered over HTTP and HTTPS. And then finally, a heat map, which is one of the key components that lets you easily troubleshoot a network that could be not tens or hundreds, but thousands of devices. In terms of pricing, Orchestrator is included with any EdgeConnect subscription. So as long as the customer is paying their $199 per month per site, the Orchestrator is something that's delivered along with that and already fully licensed. And then finally, there's Unity Boost. Unity Boost is an optional performance pack. So as a customer builds out their software-defined WAN, they might find there are some locations that are suffering from latency or don't quite have enough bandwidth. And we can address that with the Unity Boost performance pack that features latency mitigation, data reduction, advanced compression type techniques, really traditional WAN optimization techniques that we can license as and when needed. So as an example, a customer could choose to do Unity Boost for just their international locations, or they could choose to do Boost for just their replication application. Whatever it is that makes sense that they need that additional performance boost.
What's the additional cost of that?
So Unity Boost is also licensed as a subscription offering. It's $5 per megabit per second per month. So that's a very small number, obviously, but as you add up your sites and you add up the megabits per second, that's how you license Boost.
So of megabits per second of your provisioned WAN.
Megabits per second of your provisioned WAN bandwidth that you want to optimize.
Okay.
Yes. So I mentioned earlier that the EdgeConnect platform itself comes in two flavors. There's physical versions and there's virtual versions. The way that we've partitioned out the physical product line is that we've gone with what we like to call short sizes. So as opposed to the old thing where it's numbers, we've gone very simple: extra small, small, medium, large, extra large in terms of how we've named the platforms. The pricing is displayed here above on the chart as well, and you can see that the way we've priced this hardware, if you were to look at the components that go into this, it's pretty clear that we're not actually trying to make a large margin on our hardware offering. The solution is licensed basically as a subscription offering, and that's the way we like the customers to think about it. It's a subscription offering. You can run it on a virtual platform. If you're not comfortable with that and you need hardware, we're providing the hardware to enable customers to use our subscription offering for software-defined WAN. The way we've partitioned it out, it's quite simple. There's two devices that are really dedicated towards the branch. There's the XS, the extra small, and the small that are looking for branch locations. On the higher end of the portfolio, there's the large and extra large that are really designed for a data center. So that's pretty easy to figure out which sort of box do you need. In terms of choosing, hey, do I want extra small or small? Typically what customers are going to do is they're going to look at what are the physical interfaces, and what kind of redundancy do they need? Do they need power redundancy or SSD redundancy, things like that. So we try to make it pretty simple for a customer to figure out which is the right hardware platform they need for a particular office.
Do they have to buy the hardware, or can you build that into this monthly cost of the overall service?
The way the solution is priced right now, the hardware is priced differently to the monthly cost of the solution, and we kind of did that on purpose. So we look at it as, let's say you've got 100 sites. The first thing you're going to do is, okay, I need my $199 per month per site. And then I may decide that, well, 50 of them need hardware and 50 of them need software. So I'll buy the 50 hardware today. But maybe that'll change 2 years from now, and I won't need the hardware in those locations. And then you can kind of reuse the license, right? So the license can be floating from hardware to software or into the cloud.
Okay, cool.
As I mentioned earlier, it comes in a virtual offering as well. Slide is a bit simpler here. It's an OVA or a VHD that the customer downloads, deploys on a hypervisor. We support all the 4 common hypervisors today: KVM, Xen, vSphere, ESXi, Microsoft Hyper-V. We also support 3 common cloud environments: VMware, vCloud Air, AWS, and Azure. Again, it's pretty simple. Download the software, and the subscription license is available. I mentioned Orchestrator a little bit earlier. I'm going to go into a little bit more detail on some of the components there. There's a screenshot you can see on the left of lots and lots of sites that are deployed with a nice mesh of green tunnels going everywhere. First thing that Orchestrator does is centralized tunnel configuration and maintenance. So as we look to build networks that are, again, not tens or hundreds of devices or nodes, but thousands of devices, everything needs to be automated. We can no longer go and type CLI commands in or even try and apply templates from a user interface. We need to have centralized control that is ensuring that the network is always in compliance with what the customer's business intent policy is. So one of the first things that Orchestrator does is manage that overlay. It builds all the tunnels. It makes sure that they're all configured appropriately. Makes sure that the business intent policies are applied. Business intent policies is something we'll go into in a little bit more detail in some of the slides, but the way we think of the business intent policies is that the customer doesn't want to think about what kind of cross traffic classes do I need in this location, and what kind of error correction do I want turned on in this location. The customer wants to think about their applications and how should the network behave for those applications. So the customer wants to think about what kind of network behavior do I want for voice over IP? What kind of network behavior do I want for my ERP applications or whatever it may be? Because it's centralized and because the orchestrator is always making sure the network's in compliance, you no longer have these problems where somebody changed something at one site and I don't know what happened and I've got to go and troubleshoot it the next day. As part of zero-touch provisioning, which we'll go to in a little bit more detail, the orchestrator, of course, does device authentication, make sure that we're bringing the devices onto the network that we know are for our network. And one of the key points here on the bottom of the slide is that while orchestrator is responsible for ensuring business intent policies and ensuring that the network's in compliance, the orchestrator is not in the data path. So should the orchestrator become unreachable, the network still functions and everything still works. And that's a very, very key design decision we made early on. In addition to centralized fabric control, of course, it's giving you visibility into your wide area network health and visibility into all your applications, not only traditional on-prem data center applications, but also cloud applications. I mentioned earlier that we're designing this to scale to thousands of devices. And one of the things that customers asked us early on is that the typical network engineer comes into work at whatever time he rolls into work, 8 or 9 o'clock in the morning, and someone comes to him and says, last night the replication job failed, or last night the CEO was trying to prepare for his video conference and something went wrong. Well, how do we figure out what happened 2 a.m. last night when it's 8 o'clock in the morning right now and there's thousands of devices on the network? So we developed a heat map to solve exactly that problem. The way the heat map is designed is that if you look down here on the left, these are all your sites or your locations that are in your network. And then each sort of large column represents a day. And then each pixel in this screen is the state of that device or that site on that day. So if you look into Orchestrator and everything's green, of course, you're pretty confident that, hey, the network's not the problem. But if you look here and you see, well, there's a bunch of orange squares all in a row there, well, we know that that particular site had a problem for about 15 hours. Or instead, we look down here and we see all this vertical string of red, then we know that hey, something happened to the network and affected multiple sites all at once. Then you can go double-click on that square and find out what was the particular issue, what happened. In this particular case, it's that the tunnel state is down. The heat map itself can look at many different dimensions of the network. So in this simple example, it's the tunnel is down, so it's an alarm condition. But you could also have the heat map looking at what is the latency characteristics or the loss characteristics of the network. So perhaps this is your voice overlay, and you've set red, yellow, green thresholds for how much packet loss voice can take. So you would know that perhaps if there was a voice issue, let's go look at the heat map for the voice overlay, and let's see, is everything green, or was something yellow, or something red? Did we have a loss issue that affected voice?
So in that heat map, can I see that a certain set of mesh connections are down while other mesh connections are up?
The heat map doesn't show you that, but the topology screen does. Mm-hmm. So if I won't go back all those slides, but that first slide that I showed you with the orchestrator with all the green lines going everywhere, that would show you that, hey, there are links down or parts of the mesh are down. Mm-hmm. They would color code red or yellow depending on what's going on.
Maybe a better question is, can you group them in that heat map? Can you group the sites? So East Coast, West Coast?
Yes, you can definitely group
state.
sites. So we have a few different ways to do that. So you can group things like you said, East Coast, West Coast. But I think more interestingly is that you can do this on a per overlay basis. And I haven't talked really about the overlays yet, and I'll go into some detail there. But the overlays kind of, like I said, are what implement the business intent policy. So an overlay might be for the voice traffic or for the ERP traffic. So as opposed to necessarily segmenting it out by physical region, you're segmenting it out by what are you actually trying to accomplish.
Yeah, and I only asked just around so all of New York City is out. Well, okay, the provider in New York City is having an issue, right? So. That's right. And again, you can set up as many geographical groups as you like and with subgroups and everything like that.
So is the overlay a way to get scaling? If
Yes.
you have thousands of sites, full mesh is a big problem.
Yes. Yeah. So I'll talk about that right now on this slide. So
Okay.
the way that we think about the overlay is that the first thing that we're trying to accomplish is that we're trying to virtualize the transport, right? So we want to be able to leverage multiple connections, whether it's MPLS or internet or 4G LTE. So we're going to abstract that, give you a virtual overlay on top of that network. That is to the point of the question, the full mesh of IPsec encrypted tunnels everywhere. So we're automatically deploying that. And then on top of that, we're giving you the capability to deploy these business intent overlays. So the way the business intent overlays look is that, so for my real-time applications, there's certain characteristics I want from the wide area network. And we're going to make sure that the network performs to the characteristics that you've deployed, that you've asked it for it to do. So as an example, which may put some of that into a little more clarity here, here's the network. We've got the underlying physical transports. We've got internet, MPLS, 4G LTE, whatever it may be. We're going to build the full mesh of IPsec encrypted tunnels. And then the way you're going to define your overlays in this example is that you're first going to define what's the access policy, what traffic do I want to allow into that overlay, what kind of topology do I want for that overlay, what kind of connections do I want to use, and finally, what kind of quality of service do I want that overlay to deliver. So here we've defined a VoIP overlay, and the access policy for that happens to be whatever's on the voice VLAN. And because it's voice, we want it to be full mesh, and we want it to leverage MPLS and LTE, and we want the highest quality of service that we can possibly get. Second, we're going to define an overlay for our enterprise applications. That's going to be things that match the data VLAN. Because we happen to have two data centers, we're going to have a dual hub and spoke topology for that network. We're going to leverage MPLS and internet to give us the maximum amount of bandwidth. And we're going to have a maximum availability quality of service delivered to that. And then for fun, we're going to also have a guest Wi-Fi overlay as well. And the guest Wi-Fi overlay is going to be everything that matches the guest VLAN. It's going to have a hub and spoke topology. And we're only going to use the internet for that because we want to just give it best effort. We don't want to give it any kind of guaranteed quality of service. So the overlays, yes, they let you scale your network because they're what let you think about how do I want the network to behave for a particular application or a class of applications, and let you manage that network at that kind of level of granularity without thinking about individual sites. Because we're going to take this overlay and we're going to make sure that the orchestrator is applying that throughout the whole network and making sure that it's always in conformance. So if, for an example, a particular site changed an IP address because DHCP changed, overlay is going to make sure that the mesh self-heals. And the orchestrator is going to make sure that the network is still functioning the way that you asked it to perform.
So in terms of using that for scaling, if we looked at that voice VLAN intent, it's still a full mesh. So to Terry's point about if you have 1,000 sites, your overlay defines that I want a full mesh between 1,000 devices, right? So I like the idea of the different policies for different things. It seems, in some respects, it almost makes the problem worse, though, because on top of my 1,000 connections for the full mesh, now I'm adding another set of connections, a partial mesh for the enterprise apps, and then another mesh for guest Wi-Fi on top. So it's almost the opposite of scaling in some respects. I guess it copes with it, but I wasn't sure if it was going to be that it would have multiple clusters to minimize the links, which was maybe what Terry was driving at when he was asking about how far that scales. And
I see. Yeah, no, so the goal is that we need to be able to fully mesh all the sites and all the network and make sure that network is fully deployed. So you could take an approach where you try to break things out regionally and do little clusters of things, but finally someone's going to add a site and where does that belong? And that's going to have to involve some user to decide which cluster that belongs in and so on and so forth. So we designed this from day one to scale to the thousands of sites. And the orchestrator is going to manage that full mesh. I talked earlier about zero-touch provisioning, and so I'll run you through a little bit about how that works. So again, the goal of the way we're building an SD-WAN fabric is that for branch and retail locations, it's easy for somebody to plug in a device and then have all the control be at the orchestrator where the person who's managing the network is sitting, perhaps in the data center. So the way that works is someone pulls the device out of the box, plugs in power, plugs in the network, and the first thing that that device is going to do is get an IP address via DHCP and then connect to the Silver Peak Cloud portal. So that's a portal that we host. And the main job of the portal in this example is to perform a rendezvous function. It's going to rendezvous that device to the end customer's orchestrator. So the cloud portal looks at the serial number of that device. Because of that, we know who is the end customer. And then the portal will tell the end customer's orchestrator, hey, you've got a new device on your network. And then the administrator that's sitting at the data center with orchestrator is going to get a flashing green light saying, hey, there's a new device. Do you want to accept this or deny this onto your network?
And what's the protocol for that rendezvous with the cloud portal?
The protocol for that rendezvous with the cloud portal is HTTPS. It's a Silver Peak portal. The DHCP address, we look at the DNS address and up and running. I'm going to talk a little bit about dynamic path control. I'm sure this is something you guys are all familiar with, that many of our customers come to us and say, you know, I'm paying for 2 networks today. I'm paying for 2 MPLS networks, but it's not active-active. Most of the time, it's active backup. Why is it active backup? Because it's too complicated to make it active-active. It's too complicated for me to have, for me to provision every single site such that it leverages both networks. And what that means is obviously wasted money, wasted bandwidth, and it's just too complicated to manage. So dynamic path control is something we developed to solve that problem. The way dynamic path control works is that we're managing, in this example, we'll just talk about 2 links, but it could be several links. And we're choosing the right link depending on the performance guarantees we want a particular application to have. So in this example, we've got either 2 MPLS connections or 2 internet connections or MPLS plus internet. And we're guaranteeing that the critical real-time applications, the SAP application, is taking the lost path. And then for the rest of the applications, the file sharing, the internet access, whatever it may be, we're going to load balance them across both available paths that we have.
So how dynamic is this?
How dynamic is this? It does sub-second failover, and it's sub-second deciding which link to use. So it's real time.
So you can wind up with out-of-sequence packets then?
You can wind up with out-of-sequence packets, and we'll actually talk about what we do for out-of-sequence packets in a couple of slides. One of the key things to understand how we're able to deliver this is because we do have the full mesh of tunnels point-to-point across the whole network. And so we're measuring every single packet in real time. We're sequence numbering every single packet across the network and looking about and measuring the latency on every single packet through the network as well. So we can do all of this in real time. I mentioned earlier about path conditioning. So some of the techniques that we can employ to make an internet link behave like it's a private line. I'm going to go through it first in just the simple case of let's pretend there's just one link and how does this work? And this will go to that question about out-of-sequence packets. So one of the first things that can happen in any unreliable network will be that you can lose packets. So what we do is employ a technique that we call forward error correction to fix that. In this very simplified example, we've got 3 packets that are going across the network. We're going to add a parity packet to that. The parity packet, think about it very similar to how you would think about RAID in a disk subsystem. We're calculating parity for all those previous 3 packets, sending that along with the other 3 across the network. If one of those packets gets lost along the way, we can reconstitute that lost packet on the remote side of the network and deliver it to the application. So the application's never going to see that packet loss. We've completely removed that from the network. Same thing with out-of-order packets. Because there's multiple links in the network, packets could arrive out of sequence. We've got a sequence number on every single packet. So in this particularly simple example, we send packets 1, 2, 3. The network or combination of networks gets them out of sequence. We detect that on the remote site, reorder it, send it on to the application. The application never knew that the packets were out of sequence.
So how long do you wait on an out-of-order packet?
By default, we wait for 100 milliseconds. It's a configurable timer, but that seems to be working pretty well in so far in our experience.
And that works for VoIP?
It works for VoIP, but you can also lower it as well. But yeah, that works.
Before you jump ahead there, on the parity, what is the impact on bandwidth utilization on that? I mean, obviously you're adding additional flow or additional data.
You're adding additional bandwidth. Yeah, exactly. So I went through the pretty simple example here of, hey, there's 3 packets. We're going to add a parity packet. So that's you can work out the overhead on that. How it actually works, the applications are a bit more. The algorithms are a bit more advanced than that. So they're more like 4 and 40 and things like that. But we actually measure the loss in real time, and then add or crank up the forward error correction, if you like, as and when we see loss. So because we're sequence numbering and timestamping every single packet, we know, hey, there's no loss, there's no need to add forward error correction. As we see the loss increase, we'll increase the FEC ratio.
Okay.
And then if the loss decreases, we'll decrease the FEC ratio.
Does it ever go to 0? Like if it's
Yes,
a
it goes
fully
to 0.
operational, no loss network, you're not doing any forward error correction, and then only when loss starts getting introduced, then you start adding higher and higher levels based off of that loss.
That's exactly right.
Okay,
Yeah,
thank you.
Yeah, it can go to 0. Yeah.
Are these features a function of the SD-WAN product, or do they require boost?
So the forward error correction, the path conditioning, the packet order correction is all in the SD-WAN product. It's a really good question. And one of the reasons we made that decision is that the way we wanted the SD-WAN product to work is that, almost by definition, it needed to support internet links. And this is one of the key things that you need to do to make internet links perform reliably. And the way we carved out the licensing is that the Unity Boost, the WAN optimization that it's adding is essentially deduplication and latency mitigation. Think about it about those 2 buckets. So things that could make the network sort of perform faster, whereas what's built into the SD-WAN offering is what can make the network perform reliably and guaranteed.
So you can get in some pathological cases here where high jitter looks the same or seems to look like the same as packet loss. And because you're adapting to this and starting to do the forward error correction, you're adding more data to the line, you actually wind up reducing significantly your available bandwidth. How does the product handle that?
Ask the question again.
Okay, so if you wind up with high jitter, okay, so the packet is in-queued and it's going to get transmitted. But because it's out of your 100 millisecond or whatever the time window is, it looks like packet loss. Mm-hmm. Okay, so now you're starting to inject more packets to account for that and do your forward error correction. But at some point, it's almost like TCP retransmitting. All of a sudden, you've gone to half your effective bandwidth because of the retransmissions.
Yeah, we haven't really seen any kind of case like that's happened in the real world. Mm-hmm. The way the buffers are set up and the way the timers are set up, we don't really see it run into that kind of an issue.
There's a lot of automatic adaptation that goes on in there. So we're looking at the history of what's happened on that particular tunnel relative to jitter. And so the 100 millisecond default that we have is the maximum it will go up to. Mm-hmm. But it's actually an adaptive threshold, so it's looking at what's happened in the past to figure out if the jitter's low and there's been hardly anything come late, that's going to be cranked way, way down to like 5 milliseconds or something like that. So yes, there's a lot that's going on under the hood to make it work well across a whole range of real-life conditions. And it's not as simple as the pictures to make it work. So yeah,
that's what I was asking for.
So I'm sorry to jump in, but that's something we developed many years ago, and so we've gotten tons of experience in the field with what do we need to do to make it work across a broad range of situations. But the other thing that is important is what is the cap of the ratio, and so that's configurable. So it will go between 0 and, for whatever overlay you're talking about, a particular cap. Mm-hmm. And Damon's going to get to that soon, I think, when we talk about bonding policy. But you want to make sure that you don't end up in a situation where you're just adding more and more overhead indefinitely to no end. And so we do monitor, how effective is the overhead that we're adding, and if it's not having the effect we want, we will stop adding the overhead. But it is a tricky problem. So your questions are kind of right on, but we've taken that, automated it, so that the user doesn't have to worry.
Do you have any control over that so for example, if I define that voice MVO, I may want to say, look, I know that the jitter buffer is only like 20 milliseconds on the phone or something. Can I say, look, for that overlay, max it out at 20 milliseconds. There's no point waiting longer than that because it's dead data after that anyway. Rather than saying, oh, we'll wait up to 100 milliseconds and then I'll send the data and the phone's just going to drop it on the floor because it's gone beyond what it can cope with.
Yeah, you can control everything per overlay, and that's actually the idea.
That's pretty cool.
In that we want to be, when we're making measurements, we want to be making measurements for each overlay and for each physical link, and we want to have the granularity to control things.
You can have multiple overlays per link, right? So you can have one overlay just for voice and another one for FTP and another one for...
And I was just trying to check that when you define the MVO as an administrator, can I say, I know this is a voice one, here's where my jitter buffers are, I'll set it to that as a maximum before giving up on the packet or reconstructing it from FEC.
Yeah.
Damon's
going to get to it, but the idea is that we want to be able to, actually might be Rolf, but we want to be able to describe the service in terms of the SLA we're trying to meet. So for voice, we've got a jitter SLA, and then from that we derive how all these things inside need to be set.
Okay.
But yeah, good questions.
So I talked sort of simply about how forward error correction and packet order correction work on a single link. Of course, with an SD-WAN, you've got multiple links that you can leverage. So with our SD-WAN product, we took that sort of to the next level. Again, it's a pretty simplified example, but we've got 3 links. We've got internet, MPLS, and 4G LTE. And we've got a technology that we call tunnel bonding, where we bond those links together. And then we can do things, again, at the business intent level, where, hey, I want to use the internet and MPLS links for one of my traffic, and if both of those fail, I want to go over to 4G LTE. And I want to use only 4G LTE as an absolute backup because I'm paying for it by the byte and it's more expensive. So as an example of what we can do here, once we've got multiple links, and this sort of goes back to some of that question, is for something like voice, we want to make absolutely sure that the voice gets from point A to point B. So we've got an ultra-resilient packet delivery mechanism that takes that forward error correction sort of to the next level. We know we've got 2 links. And so instead of doing sort of the simple example before when I said it's 1 parity packet for every 3 or 4 packets, we're going to do 1 parity packet per original packet. So we're actually going to sort of double the bandwidth that we're using, and we're going to take the original packets, in this example, put them on the internet link, take the parity packets, put them on the MPLS link, transmit what was 4 packets, now 8 packets across the combination of both links, and then reconstitute anything that's lost on the remote site. Now, the way we've done this is that the end result is that you could lose any 3 of those 8 packets, and we're still able to deliver all the packets to the end application. So it's a very powerful technique. Another way that you could choose to approach this problem is that you put all 4 packets on the internet link and all 4 packets on the MPLS link, not using parity, just copying the packets. The problem with that is if you lose packet 1 on both links, you've lost packet 1. Because we're doing forward error correction and we're doing it across the bonded tunnel, we've got much more resiliency than a simple, hey, let's copy each packet scheme. For a different business intent, for something where it's, hey, I just need to get as much data as I can from point A to point B, hey, it's my replication application, let me leverage as much bandwidth as I possibly can, you can build an overlay that leverages both links to give you the maximum throughput. So in this case, we're going to take all the packets from that application, all 8 packets, spread it across both links in proportion to the available bandwidth, and get all the data from point A to point B. Again, configurable on a per overlay basis, right? So the voice overlay, you want the ultra-resilient packet delivery. The data overlay, you want us to make the most available use of the bandwidth that's available.
And so this is many of the same concepts there as what was related to a single link forward error correction in the latency being tunable on the remote end. So I mean, per packet load balancing sounds amazing, but it's also very, very concerning when it comes to out of order and those types of things.
Exactly.
And so like you could say per packet load balancing within a 5 millisecond window, and then if that's not really operating well, we're just going to go across one path. Is that tunable?
Yeah, exactly. So I didn't have that slide in this deck. I think, Rolf, you have that slide in your deck, right? So, and we'll show you in the demo. So on a per overlay basis, I had that simplified example that was sort of graphical, showed, hey, voice overlay, voice VLAN goes into the voice overlay. But within the part of the product where you're defining what's the ACL, if you like, or the access policy for a particular overlay, you're also defining what are your brownout and blackout thresholds for that overlay. So this overlay needs to have 100 milliseconds of latency. It has to have 0.1% packet loss and 20 milliseconds of jitter, whatever it may be. You're doing that on a per overlay basis.
Okay.
And we'll show you a bit about how that gets configured when we do the demo. The final thing I wanted to cover, just because we're going to show this in the demo as well, is a partnership that we have with Zscaler for direct-to-net security. So yes, Silver Peak's built a secure 256-bit AES encrypted overlay. We can make sure that only good traffic enters the overlay. But there are lots of customers that obviously need some kind of advanced threat protection for that. So we've partnered with Zscaler so that in the branch office, we can take traffic that's internet bound. Well, we can take the good trusted traffic, send it to the data center for the enterprise applications. Traffic that's internet bound, we can send up to Zscaler, have Zscaler do all the cleaning, bring it back to us to let back onto the network. So we're going to go through a demo of this as well so you can kind of see how it works, but I wanted to cover at a high level what that looks like. So before we go to the demos, any questions?
Firewall capability?
Firewall capability. So today in the product we have the WAN hardening. We're implementing a stateful firewall capability as well, and that'll be coming out in our next release.
So the ability to deploy multiple VLANs on the edge, or
so multiple VLANs on the edge we can do today. So there's exactly what you mean by firewalling, but today available in the product is there can be multiple VLANs on the edge device, and they can be fully segregated.
Can you give me an idea of largest customer sizes?
So largest customer sizes, and David might want to jump in here as well. It kind of depends what you mean by largest. You mean, who's the biggest customer that we have in terms of brand name, or by locations, or
by size?
By size. So
I'm not particularly interested in who your customers are specifically, but how big does this thing scale?
Yeah, so we've got multiple deployments today that are in the several hundreds of nodes. And so I think that's answering your question directly. Yeah.
IPv6 support, both in the overlay, you can encap that, or then use it in the underlay?
Yeah, IPv6 support is in the product today, yeah. Okay. So we can do both IPv6 on the LAN side and put it into an IPv4 overlay. We can also build tunnels that are using IPv6. Building an overlay using IPv6 tunnels.
Multicast support. If I have a multicast app, can I push it through the overlay?
So today what we do for multicast is the multicast is going to go on the underlay. We don't today participate in the multicast tree.
Okay, so I lost you on the first statement there. Participate in the underlay. So you don't deal with the multicast tree. So if a multicast packet needs to traverse the WAN, and what happens? So
the multicast packet is just going to go on the regularly routed network.
So yeah, two ways. If say there's an MPLS network, then there's an underlay there, and we're an overlay on the MPLS network, so we can let it go through on the underlay as it was before we were there.
As a pass-through, effectively.
As a pass-through.
Yeah.
Or you can set up a router that's in the location that's doing the multicast today with a tunnel through us, so that it's going through our load balancing and all the rest, but we're not participating in multicast. So there's two ways of supporting multicast, but they're not native on our product.
Is there an architecture for hardware redundancy if I want to have two SD-WAN appliances at the edge?
Yes, you can do hardware redundancy. And there's lots of different ways that we can do that. We built a bunch of hardware redundancy techniques from the WAN up days with things like VRP and WCCP and policy-based routing. So all of those same techniques are available with the EdgeConnect portfolio as well.
Okay.
You said you could take V6 and tunnel it through V4.
Yes.
Can you go the opposite? Can you tunnel V4 islands
you could do V4 into V6, yeah. Yeah.
Did I miss something on handling VoIP or real-time applications? I may have been making notes or something.
That's okay.
prioritization, basically QoS.
Yeah, you didn't miss it because I didn't cover it. But we have a full, rich suite of QoS functionality. So, a very quick answer. Full application classification, which is the first thing you need to do, recognize the application. Then within our device, we can do min-max bandwidth guarantees, absolute prioritization, guarantee minimum wait times. And then if it is an MPLS network, we can tag as well.
Does that happen automatically, or do I need to set that up in the Orchestrator?
So by default, if there's already tags on the LAN side of the network, we're going to copy them over. We also have a default set of quality of service that's built into the product for things like voice, which it's pretty obvious what you want to do. Then you can obviously take those and modify them to your heart's content. And that's all, again, centrally managed by the orchestrator, right? So once you define a QoS policy, which we'll show you'll actually do via your overlay, then that's made sure that that's maintained throughout the whole network.
You may have mentioned this, but how do I get traffic to the Unity box? Is it WCCP or static routes or?
I actually didn't mention it, but when you asked the redundancy question, we talked about it a little bit. So multiple ways that the appliance can be deployed. Can be deployed sort of inline in a, quote unquote, bridge mode. Yep. It can be deployed with WCCP, policy-based routing. It can be deployed as a simple layer 3, almost just like you would a router. Let's plug in both LAN side and WAN side.
If it's as a router, does that mean it will participate in my OSPF or BGP domain?
Great question. So BGP and OSPF, where we've integrated that software, those routing stacks into our software right now. That's coming up for production release in our next code release.
What's the impact of running the dedupe on a smaller box like this that doesn't have like an SSD or a hard drive in it to do like the caching of?
Yeah, so all the boxes have SSDs in them.
Oh, they do?
Yeah. Simple answer to the question. The other thing is too, I won't go back to the slide, but when I had that slide that showed all the hardware options, there's a range for the SD-WAN functionality, and then there's a range for the boost functionality as well. So you can decide what's appropriate for your site, given that you may or may not want the boost.
I thought I saw on that slide, though, that the two lower ones didn't have an SSD, but they all do?
They do. It's that the two lower ones aren't redundant.
Okay.
Yeah.
Just clarity on one more thing. You said, I just want to make sure that is understanding. You're doing end-to-end segregation of traffic based off of overlay. So you have a guest wireless network. We want to deliver that to the hub. We don't want that meshing. I'm concerned more about like compliance concerns along those lines for like a branch location. So you're able to say that from end to end, I'm delivering it differently and I can split it out how I need to at whatever site.
That's right.
With no interaction between the two.
That's right.
Okay.
That's exactly right. Yep, that's the power of the overlays. Yep.